Hello and welcome to another video, and this one is about multiprocessing. This actually came up on stream. I was talking about a refactor that I did at work when I changed the test runner, and I sped up the test suite by doing some reordering of the tests and made the slow ones run first, and it made a pretty significant difference into the runtime. And someone in chat asked, well, why does slow things first make things faster? And more generally, why does knowing about how long a task is going to take, why does that improve the effectiveness of using multiprocessing or job scheduling or anything like that? So let's jump into it. I'm going to draw you a little diagram explaining why that happens. Okay, so I'm going to grossly simplify the problem a little bit here. We're going to talk about some arbitrary work units, and we're going to have two workers that can process these units, and we're not going to have any dependencies. It's not going to be a DAG. It's basically just, otherwise equivalent work units. If you have a DAG, obviously this problem changes a lot because you need to make sure that you're satisfying dependencies before you run particular work units. But we're in a very much simplified world. The advice still applies to dependency management and having to resolve some task graph, but it's much more complicated to explain and doesn't, I don't think it provides any more useful information than what I'm going to show you here. Okay, so we're going to represent the two workers just by some just by some curvy lines over here. That'll be worker 1, and this will be worker 2. And we're going to assume that time increases linearly in this direction. So you can imagine this being time here. And we're going to have some work items that we need to accomplish up here. So let's say we have a bunch of, these smaller work units. We're going to turn transparency off. So let's say we have a bunch of these small units of work, and again, the width of these is representing how much time they take. And let's say, just for the simplicity of describing this, we have one, longer unit here. So naively, the way you would schedule this, if you didn't have any time information, like you didn't know that this unit was longer than all the other ones, you would just schedule this in a first come, first serve and kind of a round robin way. Like when you have an available worker, it will pick up whatever work is at the beginning of your queue. And so if we, let's color these in a particular, color these green. We'll pick something that's colorblind friendly, and we'll use orange for this one. So you might imagine the way that this gets scheduled. Let's say that it pulled things in chunk sizes of 3 to make this simpler. You might imagine the work gets scheduled like this, and then these get scheduled here, and then some worker picks up this big task here. And you can see that this entire chunk of time here is wasted with the second worker. The second worker is idle while this runs here. And so, you complete eventually at this time here. So that's for kind of our first case where we don't know anything about it and we weren't able to reorder things intelligently. But as soon as we know the timing of a particular worker, we can do much better than it's kind of the naive scheduling. And the simplest scheduling, or at least the algorithm that I roughly used to order tests, was to take some historical test information data and put the slowest tests first. So I did that by taking this and scheduling this one first. So we get this big chunk out of the way. And while this big test is running, we can schedule these smaller tests in here. Just this. And maybe we get 2 more out of this one. And then we have these 4 remaining to schedule. And so we schedule these 2 here and these 2 here. Basically getting a perfect packing here. Like maybe we have like a little teeny tiny bit of wasted execution on this second worker here. due to the idle period. But oops. And yeah, so now our new completion time is right here instead. So you can see we saved a whole bunch of time just by reordering the slowest things first. And this basically just makes it so this bin packs a little bit better. Of course, your real situation may be more complicated. You'll probably have more workers. You'll probably have more different non non-homogeneous work items, and you may have dependencies and other stuff and more complicated scheduling. But this generally holds for that as well. So the general strategy is do the slow things first, and then bin pack. You can better bin pack the small things towards the tail end of your execution, and you tend to waste less work. Now, there are other strategies to optimizing multiprocessing. Like one problem with multiprocessing is if you have a lot of very small units of work, you spend a lot of time context switching between each of those small units of work. And so you may want to end up batching small pieces of work as well. So you end up with you send 3 work items to a worker at once instead of sending one and then waiting for a response, and then sending another and then waiting for a response, then sending another. There's a lot of context switch time between sending those. So that's another strategy that you can use as well. I actually use that strategy as well when optimizing the test times at work. There's an option to the parallel test runner that I was using that allows you to batch items that are within the same scope or within the same file. And that made not a lot of difference in the overall runtime, like maybe a second for 1,000 tests, but it made a significant difference. And every second matters when developers are waiting on that time, and so it expands out to a lot of save time, save money. But anyway, I figured I would show you this little diagram and hopefully explain why reordering tests based on reordering work units based on knowing their duration can be helpful. Of course, you might not have that duration information, so you might not be able to do anything with this at all. But anyway, hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.